All right, welcome everyone. Thank you so much for joining today. So my name is Bo. I'm the Director of Growth at Acelab. We are helping out with hosting today's event. I'm going to give a quick little introduction, just a few minutes, give some folks some time to join, and then we'll go ahead and get started with the AIA portion of today's event. All right, so today we are learning about restoration and retrofit construction. And we've got Mark Brusso here presenting for us today. Mark Brusso is with Blok-Lok, which is the Canadian division of Homan & Bernard. So if you've come to one of our webinars in the past, you might have come to a Homan & Bernard webinar with Linda Potter. So we're really excited to welcome Mark today to present this topic. All right, and as I mentioned, I'm with Acelab, so we are helping out with hosting today's event. Acelab provides free, non-sponsored product research. Our platform is completely free and open to use for architects and specifiers. This is a quick snapshot of some of the members of our team. So Acelab was started by architects for architects, really with the goal to be able to address some of the workflow issues that we were seeing ourselves in practice. So our goal is to win back design time, allow you to design better buildings, and be able to provide the vital product information that you need all in one place. So here's just kind of a quick little diagram of some of those workflow issues that we are working to address. And with that, I'm going to hop over to the Acelab page really quick, just show you how to get in touch with the Homan & Bernard team. So that's kind of the USA division of the company. So if you have any questions related to, projects that are located in the US area, you can direct them over to Homan & Bernard. If not, we'll put you in touch with Mark Brusso. All right, so once you log into your Acelab account, you get this handy dashboard with all of the work that you've been doing on Acelab. You can converse with reps directly on the platform, upload projects to keep everything organized, save products to your projects, and also keep a record of all of your searches. And up here at the top, we've got all of our searchable product categories. So you can use those to be able to kind of explore and discover new products. And if you know exactly who you're looking for, you can always type that into the search bar right here at the top. So I'm going to type in Homan & Bernard, head on over to their page, and just show you how to reach out to them. So this is a great way to get some additional information after today's event. You have a direct button to contact them right here. So that's all you need to do to get in touch with the Homan & Bernard team. You can ask them project-specific questions, product-specific questions, whatever you like. And those conversations all happen directly on the Acelab portal. You can get back to those conversations just by hovering over your library and going to your Conversations tab. So here you can see a record of all of the conversations that you've had, and you can filter them down by project as well. All right. So today is an AIA-approved course. We did ask for AIA numbers upon registration. I'm also going to send a link to a form in the chat in just a moment. So in case you're worried that you didn't include your AIA information upon registration, you'll have a second chance to do that in one moment. And let's see, I also want to encourage folks to ask questions. You can ask questions throughout the webinar in the Q&A. We're going to save some time at the end to be able to address some of those. If your question goes unanswered, we will have a record of it so we can follow up after the event as well. And then one last thing to just kind of keep an eye on the chat throughout the webinar. I'm also going to send over a link later today. Acelab is getting ready to launch kind of a version 2 of our platform. We are finalizing some of the designs there. So I just wanted to extend an invite to anyone in the webinar today who's interested in signing up for a feedback session. We would love to hear from you, and it gives you the opportunity to see your feedback incorporated directly into the tools that we're building. So if you're interested in learning more about Acelab or having a chance to incorporate some of your feedback into the stuff that we're going to build, that'll be a great opportunity to do that. So keep your eye on the chat for the link for the AIA sign-in, as well as a link for a meeting for that as well. All right, and that takes care of all of my housekeeping items. So with that, I'll go ahead and hand it over to Mark to get started with the AIA portion of today's event.
Thank you for the introduction, Bo. We already have a Q&A question. I'm just wondering if that's, hopefully it's not to do with any of my content.
So I'll answer that one.
Okay. Thank you for having me today. I've noticed we have 124 participants, so that is a record for me. I think the last presentation I did that was close to 100 was 90 attendees at one of my Canadian firms, and I definitely got in trouble for the lunch bill on that one. So this is the new record. So thank you for the introduction, Bo. I'm Mark. I'm a certified technical representative in Canada for architectural markets. And today I'm going to present on retrofit and restoration construction in a context of existing buildings. And as Bo mentioned, this is a AIA certified course, so this is in duplication, but this will be all coordinated through Bo. We will provide 1 credit after the presentation is finished. So just a brief overview of what I would like to examine today. And the main thing here is that I hope you walk away from this presentation having a little bit of fun and also learning something new, because in our line of work, I believe we're constantly learning every single day and continuing to grow and learn and new things. The learning does not stop. So I certainly don't know everything to do with regards to construction and specification architectural work. So that is constantly changing and growing as things change in our market. So I believe we're in exciting times right now in North America, in the US and Canada. And we have some very interesting things happening with regards to both types of construction. So the first thing I'd like to open up with is we're going to look at what is the main driver for retrofit and restoration construction, just a very general examination of why are we doing these types of construction with existing buildings in the first place? What is the main driver for that? These two types of construction really focus around improvement of the building envelope. So at HB and Blok-Lok, we are a company very intimately connected with the building envelope in terms of materials. And so a lot of our product focus is involved in developing that structure with best practices solutions. I'm also going to take a very general look at some of the energy performance standards that govern some of the mandates with regards to energy performance in both Canada and the US. Where do the directives come from? Because it varies from region to region, state to state, province to province. And there's many standards, but there's some important ones that I'd like to highlight. We are going to do a examination of rain screen systems and what they are and how they are tied in with the retrofit projects. What are they? What do they look like? As part of rain screen systems, we're also going to take an examination of thermal construction performance and what does that mean. I'm going to briefly look at air barrier and insulation because those components of the envelope go hand in hand with rain screen cladding systems and thermal construction. We're going to switch gears about halfway through the presentation from retrofit into restoration work. So with that, we'll be looking at specific anchors, installation techniques, and also just an overview of how we test for these things, because that is part of our offering at Blok-Lok especially. We're experts on restoration anchors. And then just at the end, I'm going to touch briefly on a couple of other methods of restoration improvements which are tied into our product offering. So other methods of improvements, namely repointing and cleaning. The 2 slides at the end covering those things. So a couple of definitions. For the context of this presentation, when I'm talking about retrofitting, what I'm really talking about is an improvement or a rehabilitation of a building in order to increase performance. And oftentimes with retrofit projects, we're looking at an existing building that has been built at some period in the past, and we are bringing it up to a new standard of performance. So that is what I will be talking about when I'm mentioning retrofitting in this presentation. In terms of what restoration is, this definition can be found quite throughout the web or other sources, but generally speaking, it's the process of restoring a building to its former state. So it's also an improvement of that building in one way, shape, or form. So what do I mean by improvement? Well, in the big picture, I think improvement is arming your building to the teeth to combat Mother Nature every single day. So one of the first things that comes to mind when we're designing good buildings and improving them is the water shedding principle. We are constantly trying to keep Mother Nature out in terms of water. We're also looking at increasing energy performance. So making insulation systems better and making sure that all of this expensive energy input that we're putting into the building is not being lost through poor design and detailing. Durability is also a method of improvement. In context of this photo, this is actually a lighthouse off the coast of France. It's called the La Joumont. Masonry is one of the most durable forms of construction on the planet. Some of the most longest lasting structures around the world are made out of masonry. And so improving these structures of durability is a very, very important component of improvement. We're also interested in increasing the longevity of our buildings as much as possible because these are very high value structures that have a lot of value attached to them. Improving the building envelope is also involved in an increase in comfort. It's involved in also aesthetically keeping the building appealing to the eye. We're also going to discuss operating costs, how the improvement of the building envelope will act to lower those. And why really are we retrofitting these structures in the big picture? Well, I would like to say that I think, generally speaking, without getting too much into detail right now, we are at a point in our history where energy prices are not going down. And we are trying to counteract the effects of increasing energy by retrofitting these structures. So I'd like to give you an example of valuing one type of energy that I'm closely associated with. So at my home, I'm located in Rockwood, Ontario. One of the primary methods of heating my home is actually firewood. So I take my firewood quite seriously compared to most. So I built a custom firewood enclosure, which is out of the elements. And in addition to that, I'm also constantly testing the moisture content of my wood for an optimal burn. So generally speaking, within one season of heating, I will go through approximately 1 bush cord of firewood to heat my home. And that will keep me comfortably warm throughout the winter. If something were to happen where my secondary heat system were to go down, which is natural gas, I could definitely count on this to be reliable over that period of time. And so I attach a very high, a high value to this type of energy because it provides comfort, shelter, and on the right-hand side there's just a little picture. That's my border collie Daisy. She also appreciates that type of energy too. So the reason we're trying to conserve energy, it is a very high value commodity. And the other important concept of retrofitting the building envelope is that we are also equipping it with a very robust, in the context especially of rain screen systems, we are now with this type of technology increasing the water shedding, insulation, and energy saving capability of the building to a new level. And again, on the right, my symbol for that being the raindrop. The most important part, in my opinion, with this improvement is keeping water out of the building envelope and keeping it on the outside. So all these improvements are very intimately associated with retrofit construction. So just to touch on the standards and codes that we are keeping an eye on, this is a very basic overview of some of the most important standards and codes governing energy performance. So I'm running into these a lot in Canada. You will also run into these in the United States. When in question of where to go when designing your structures and where to follow, where to go, my answer is when if questioning design and codes compliance, the best thing to default to is your local municipality. So essentially the governing authority of which your permit is going to be taken out, because even municipalities can vary from municipality to municipality in the same province, in the same state. So it is really very much up to the issuing building department of which you're obtaining your permits, what is governing all of these driving standards going forward. So very briefly, the National Energy Code for Buildings, NECB, that is one of the main standards. The International Energy Conservation Code, IECC, ASHRAE 90.1, more close home to Canada, the National Building Code of Canada also will outline energy functional statements. And then at the municipal level, as an example, we have what's called the Toronto Green Building Standard, which goes even further into some of these energy codes. So as an example of what you would find, this was taken from the National Energy Code for Buildings. I took out section 3.2 just to generally show what does it even talk about in that energy code. So there's a section there at very high level functional statements. And we will touch on some of these things here in our presentation. Limiting the amount of uncontrolled air leakage in the building envelope, limiting the amount of thermal transfer through the building envelope. So these are two main functions of retrofitting and improving the building envelope that involved energy. Does all of this make a difference? And the answer is yes. So retrofitting does make a difference. Following the energy codes does make a difference. And this is a graph that the US Department of Energy put out. It's very easily found on the internet. And this was actually in another presentation I attended on cladding systems. So I brought this into my own. And what it is a normalized energy use chart of from period of 1970 all the way up to about 2020, showing each step and also the energy codes introduced along the way. And it reflects the overall normalized energy use for residential, commercial buildings. And this is for the United States only. And the general trend is that normalized energy use for the buildings is decreasing as each code comes out and we develop better methods. So generally speaking, the codes and the standards are working to decrease energy use in buildings. So we are making improvements as this technology is implemented. There are also some very good resources outside of the standards that are published by professionals that are out there. And one of which was done by a professor at the University of Toronto. And this study was very interesting because this came out in response to a crisis that our city of Toronto had at this period of time, where a lot of the apartment buildings built circa 1960s and 70s, which were essentially not insulated structures at all. They were multi-story buildings, clad in brick, and had what would be called a foil-faced backing air cavity. And what was happening is these structures were over time deteriorating to some extent and also incurring humongous operating energy costs as the cost of energy would rise. And what was kind of born out of this crisis evolving was the need for an improved building envelope to counter the effects of these increasing energy costs. And so Professor Ted Kessick issued a multi-unit residential building design guide. This is a great resource to take a look at. It doesn't apply only to structures in Canada. It can be applied to any building. But it's a very well graphically illustrated report on techniques that can be used to increase the performance of any type of a building. And a couple of those key concepts are using thermal mass in walls and also using rain screens, which I'm going to touch on later in this presentation. And so what happened with that report prior to it being issued in 2019 is Ted Kessick actually got involved in a lot of recommendations for these this era of apartments. So on the right-hand side is kind of a picture of what I'm talking about. So these very, I would call them industrial or brutalistic style apartment buildings, which were clad in brick, a lot of raw concrete features and very little insulation and very high levels of thermal transfer, you know, exposed concrete balconies, no thermal breaks. And the dilemma is we had to do something about these buildings to increase the energy performance without compromising the rent income of them. There wasn't an option to move people out of the building and start removing walls and studying from the inside. So what happened and what is continuing to happen is a solution going forward of cladding this with a type of a rain screen system, and that was with an EIFS. Personally, EIFS, in my opinion, is not one of my favorite types of finishes on a building. It is extruded polystyrene with a finish coat with a drainage plane. So it is not my preferred method of doing it, but it is a great option to reclad and increase the energy efficiency and bring that R value up on a building without compromising, let's call it, the business of that building going forward. So it is a very viable way of making an improvement, a retrofit improvement to a building that benefits basically everybody involved with it, from the tenants to the owners and so forth. So this is an example of a type of retrofit construction that makes very good sense in the long run to reduce energy costs, operating energy costs on a building. Just to check there, do we have a question in the chat? No, that doesn't look like it. I think we're still good. Feel free to ask any questions. Another thing that's important is that the rain screen can be done poorly. And embarrassingly, I am highlighting this condo crisis, the leaky condo crisis, which happened kind of uniquely in the British Columbia region from the 80s to 2000s. And this was actually an example of poor rain screen design. This happened and affected hundreds of buildings throughout the province of BC. So it's very important we pay attention to the details with regards to these retrofit types of construction. And the drainage plane and the water shedding ability of these cladding systems is paramount. So there is history of things not working well and not being done properly. And we hopefully have learned from these mistakes, because the issues are still going on and the repairs are still going on. So best practices are very important to keep top of mind. So essentially, what is a rain screen? What does that mean right now as we're talking in these general terms? So as of today, when we're talking about rain screen, and specifically with regards to some of the materials that HB and Blok-Lok are providing, it's another way of bringing into a building offsetting exterior insulation outside of the vapor air barrier. So what we're doing is we're bringing a very deep drainage plane and a cladding system outboard of our air vapor barrier, and creating a very generally speaking, a wall of water resistance. So this was taken from RDH Building Science's report on cladding attachment solutions for exterior insulated commercial walls. And the core components, in a nutshell, of a well-designed rain screen, there's really not too many things involved with them. It's a very simple thing. And first of all, we're discussing some sort of an air vapor barrier, as you can see on the far left of this image. Then we are introducing a clip and a girt, or a clip and channel system, which can be thermally broken. That's an image of a Fabrica shim, which is a thermally isolated shim. There is a method of fastening this bracket system. And then the cavity can be one of a couple of different types of insulation. And then there will be an exterior cladding as part of that. And the interesting part about rain screen, what I really like about it, is you have a myriad of options for your outside cladding, from metal to glass all the way to actual wood and wood simulated structures. So there's a huge potential to design a very broad type of finish. So there's a lot of, even zinc is an option nowadays for rain screen systems. A very interesting company, Rhine Zinc, makes panels that are zinc, developing a very nice patina over time. So there's a myriad of design options with rain screen systems available. And looking at the bones of the structure, and that's something our division, our company does very, very well in terms of building envelope components, is we are involved with the supports, the clips, the meat and potatoes of these systems to a high level. We provide very robust steel-made brackets and solutions for these cladding systems. And this is an example of what a rain screen system would look like prior to insulation, just as those clips are going along and being insulated, before being insulated rather. And so stainless steel is a metal that plays a very important role in not just our rain screen bracket offering, but also in restoration construction, especially. A lot of the standards in Canada and North America mandate stainless steel for all kinds of restoration works, especially stone anchors, our helical ties. A lot of our brass combination expansion anchors feature stainless steel rod. And the reality is, the reason is that stainless steel is very, very strong. It is takes a very long time to corrode. It will outlast the life of a building in most cases. And it is a very high functioning material in terms of retrofit construction. And it also performs quite well thermally in comparison to some of the other types of offerings in terms of clips. This brief graph will show there are definitely other options out there that work for rain screen clip systems, but stainless has a very sweet spot, a good sweet spot in there for strength, thermal performance, and workability on the job site. So part of our product offering currently is we are now offering rain screen support brackets to be introduced as part of rain screen systems. This is an example of our RS system, which is a thumb clip, highly adjustable, compatible with thermal breaks, and also very versatile to be used with a girt or aluminum channel system. And the main points of a rain screen system is we're reducing thermal transfer. We're also introducing the ability to produce continuous insulation within that system. We're reducing fasteners. We're introducing thermal bridging breaks. We can also engineer the system fully if need be. As I was mentioning, the offerings for cladding system are very vast right now. Personally, I like some of the European companies that are offering the wood-based products for some of these systems. They're very aesthetically pleasing. As you can see, I'm a bit of a wood guy with my interest in firewood, so naturally I kind of gravitate towards wood design. So I like a lot of these companies coming out with these natural look rain screen systems. There's a high level of adjustability with them, which is really important with regards to the trades that we're working with on the site. I always like to hear a few comments from the guys doing the install. So one of our products we also offer is a concealed lintel system with HB. And if we do any of those or we have those going out on site, I do like to hear what the bricklayers are saying about what their pain points are. And having something adjustable is really important on the job site because nothing is always perfectly square and perfectly built as per the drawings. So we also have powder coat or anodized options for these materials. Again, it's something fully customizable to each project. This is our RS system, a little different than the easy clip system I showed previously, but this is just another option of a rain screen cladding bracket system with aluminum rails and the stainless bracket. So moving right along, close to home, I was just talking to Bo prior to my launching our presentation here. The University of Guelph, that's my alma mater, 4 years of studying and complete bliss and freedom, in my opinion. So it's kind of a place close to my heart. I miss it dearly. And every once in a while, I'll take a ride through campus just to see how things are going. And it just makes me feel darn good sometimes to go back to my old campus. And over time, I notice a lot of the buildings will change and improve and get tidied up. And the universities are always interested in making sure that their infrastructure is maintained, kept up to standards. They want students coming back. They want them being comfortable, and they also want to reduce their operating costs. So most recently this summer, they had done a retrofit of one of the residence halls, which is Dundas Hall. This is a picture of the existing structure as it was built in the 70s. So very, very basic, kind of a metal cladded, kind of ugly in my opinion too, residence hall on the east side of the campus. And it went through a retrofit. So they put a rain screen system on the building. And I took some photos of it because I thought it was really interesting to see how all these elements came together and how we could make things very good and what works well and what I could see was working well. And what I noticed is when they stripped the old cladding down, that ugly brown metal off the building, what they were left with was a very strong and robust backup of brick. And brick structures are phenomenal in terms of providing a very strong backup to connect to when you want to retrofit a building with a rain screen. And the reason is that a lot of the fasteners and the expansion anchors and the brackets, they perform so well in an intact building, intact masonry structure. So you get extreme fastener performance, very strong pullout values. Essentially, all that brick and mortar was in prime condition because that outside cladding did perform over time. It did its job in keeping the elements out. And what you were left with to fasten to is something very strong. And what was nice about this project is they used a fluid applied air vapor barrier in conjunction with some detailing around the windows. So they were able to achieve a very continuous plane of air vapor barrier with the fluid applied method. And as you can see in this picture here, the brackets were first attached onto the structure prior to the channel going in. I'll just go back one slide, and then the girt system will go in. And that was a rock salt cavity wall insulation. So that's an example of something on my campus which happened recently. And I did not get any finished pictures of it, but just down on the south end of the campus, they did a somewhat similar installation of a rain screen system on the south residences. And I did get a finished drawing of that, finished photo rather. They went with a bit of a white panel system. And what was different with this one is they went with a sheet applied air vapor barrier prior to the clip system going in. That's something that's kind of unique to the Canadian market, is we are not quite as fully developed in fluid applied systems as the US is. It's just the way things have been here for a while. But the Dundas Hall was one of the first fluid applied jobs I've seen in a long time up here. And I think it speaks to itself in terms of how quickly you can get an air vapor barrier in place and very continuous. And that's something with air barriers we're very interested in seeing, in my opinion, is we want your insulation and air vapor barrier to be as continuous as possible when we're talking about these types of structures, and in structures outside of rain screen and retrofit construction. So on the left, for example, is a school project with a fluid applied air vapor barrier. And some of those small little dark spots that you can see there, those are all reinforcing tie portions of the reinforcing steel sticking out. And those will connect into an exterior brick. And it's really important that we get all those small little crevices sealed and coated with the air vapor barrier membrane. And that's something that the fluid applied system does a very good job with, is that continuity of the air vapor barrier. So it's a complete plane all the way across. It would be very difficult to deal that with a sheet applied system with that that many penetrations. On the right is an example of one of our masonry connectors, our 213, and I took a shot of a recent project I finished in Quebec. And another trend we're seeing with these deeper cavities and deeper insulation layers is the anchors are now growing. 4, 5, 6 inches of insulation is now the norm, where 10, 15, 20 years ago, it was 2 inches. And now we're seeing things even growing much further than that. I'm confident that some of the audience today is dealing with insulation cavities much greater than even 6 or 7 inches. I've heard up to 12 in certain regions. So growing insulation cavities is definitely a trend right now that I'm seeing in our markets. And everything changes from that point, including our spans, the connectors, our air vapor barriers. So everything is changing now to accommodate these more demanding energy codes. And generally speaking, when we're talking about our air barriers, which we just touched on, it's a critical component of this cladding system in terms of controlling moisture and air leakage. And very generally speaking, when we're controlling these two things, we're controlling moisture, the elements, and also the escape of energy within the building envelope. So having a high-performing air barrier system is very critical to this method of construction. I did mention in the US, we see much more fluid applied air vapor barrier as on the left. And on the right, we're kind of catching up still. We still like to use sheet applied systems here primarily. I think fluid applied really has sheet applied beat in a lot of ways. And one of the prime reasons is it's very quick to install. So it's very productive. I'm always interested in doing things quicker. I have a home shop. I have woodworking equipment. Once in a while, I have a few customers which will come in and need some work done. And I definitely like getting things done quick versus taking a long time to do it. So productivity is key. We're able to, I think, observe better continuity of details within the building envelope and the corners and so forth. I think fluid applied really does a good job of continuity. Some of the technology and the materials that we're seeing now, I'm going to look a little bit more intimately at a couple of types of fluid applied air barriers, but some of them are performers in damp conditions, which we're definitely having to deal with on the job site. Once we're familiar with the equipment and applying this material and getting those things dialed in, it's easily trainable to use fluid applied equipment and sprayers. Sheet applied advantage, it's from a materials perspective, it's a lower cost, both in material and also in equipment aspect. So we're not having to spend a few $1,000s on the best Graco sprayer or new tips and clean up chemicals and other things once we're finished on the job. So initially, it's a very, very low input way of applying air vapor barrier. And in Canada, one of the reasons is the same trade installing the brick. So in terms of masonry buildings, will often be involved in installing the air vapor barrier. So it is a thing that masonry trades here will do the sheet applied air vapor barrier. Whereas in the States, there's oftentimes trades just dedicated to the fluid applied system. There's often priming involved with sheet applied as well. So a couple of the high performers in the air vapor barrier world, silyl terminated polyester, STPE. This is the hybrid product if we were to describe it. And it's a combination of silicone and polyurethane tech all in one. What's great about this, it can be applied to damp walls. It has very good long-term UV resistance. And what that means to me is oftentimes questions will arise on a project is how long can I leave an air vapor barrier exposed before our cladding goes on? Because over time, UV does degrade these things. And it's important for a lot of them that the exterior cladding does go on within a reasonable amount of time after installation. Low temperatures are not an issue for STP either. And another benefit is one coat application. So not a build, no primer required. So it's, I would say, a very high performing, productive fluid applied air vapor barrier membrane. High solid content is important also, so that once the product is applied, we're not getting a reduction in the coating mill thickness of the film to maintain. Low VOC is very important as well. The other high performing fluid applied barrier is silicone. What's great about this product is it's vapor permeable. Long-term UV resistance, again, like STPE. Very high application range from 0 to 150 degrees. Again, a single coat application. No primer required. Also a very elastic product. You're also able to use this in fast track, and what that means is that it is a quick product to install on the site. So if you finish a section, you're not complete during the day, it's going to rain overnight, you can finish up to one point and then start the next day without any delays, because it also is easily applied in damp conditions. So that is the first part of the retrofit portion of the presentation. Second part, restoration. This is something I'm a little more familiar with and a lot more intimately tied with up in Canada with Blok-Lok. So Blok-Lok, really between Home Bernard and Blok-Lok, the Canadian arm Blok-Lok, we're really restoration experts when you get down to brass tacks about it. And a lot of the restoration products that go into the United States market, they are fabricated up in our Woodbridge plant up here, which is just north of the city, north of Toronto. And I think restoration is a really important part of our market. And there are some firms probably today who are very intimately involved in restoration. There are a lot of firms I work with that just do restoration. And there's a very good reason for it. And the reason is that a lot of our buildings which get restored have a very high value. On the left is the Church of Our Lady Immaculate in Guelph. This is a large church that is built 1800s, circa 1800s. It's a mass stone wall construction. It is a very high value building, as it is a designated heritage building and also has a large congregation, and it is getting restored on a regular basis just because it is a huge structure and it's old and it's still valued. So there's always a budget allocated to restoring this building. These are gathering places for many different types of functions. Now on the right is a school project which I worked on several years ago, where we were working on restoring the brick veneer of the envelope. And schools are also very high value buildings, and oftentimes they're constructed out of a high amount of masonry, which requires restoration. And that's one of the beauties about masonry, is it's very easily restored because it's so many of these individual units of brick put together. And we are able to do so many things to restore brick. We're able to repoint the brick. We're able to install helical ties. We're able to rebuild certain sections that have deteriorated. And so it's very easily restored. Another example of a brick yard building at the Toronto Transit Commission. So the Transit Commission controls and provides all of the buses, streetcars, high-speed, rapid transit vehicles for the city of Toronto. And a lot of their buildings, again, are made of brick. And over time, they will deteriorate. They break down. We have a harsh climate up here, a lot of de-icing salts, a lot of freeze-thaw, and a lot of times the upper areas of these structures need restoration work. So that can comprise many different things. So we are experts on that. And with restoration, rule number one is you need something solid to start with. And you don't always have that. So this chimney came into my life a couple of months ago. One of my firms that I work with, they wanted to rebuild this. I was trying to convince them to tear it all down and not go the restoration route, but they insisted that they were keeping it because it had a solid structure beneath. But I was a little unsure of that because I saw a lot of voids in that brick wall. I wasn't sure 100% whether or not there was enough there. So we took a look at that and had a few discussions. But I think what ended up happening is they did keep that core of brick. I'm hoping it was solid enough, and then they restored the outside to keep it going. And as I was saying, you need something solid to start with. The wall on the right, I don't know where that's located, but it was a heck of a funny slide one of my colleagues put into a restoration presentation. I couldn't resist. I would not trust that wall to be something to use a restoration anchor or reclad or reskin for sure. There's way too many dark spots there. And with a lot of restoration projects I get involved with, sometimes we're not looking for something to save the building or save the world. We're just trying to keep it together. So, and what I mean by that is a lot of the times there's only a certain amount of budget and money that can be allocated to these projects. And sometimes you're just trying to keep things from completely collapsing. So this is actually a building from New Orleans, which has seen better days. And some of these red markings on the drawing are what I would call a redlined restoration drawing, which we sometimes see. And the main theme with restoration, it is kind of the red-headed stepchild of the construction industry, in that all of the principles and standards and codes that apply to new construction, they generally don't always apply to restoration projects. I had the opportunity this summer to travel to Europe and go into Italy for a bit. And I've been to the Rome before, and I did take a tour of the Colosseum, and I took a few photos because I always find it interesting to see these structures. And the reality, what I realized is that in my type of work and also in seeing ancient buildings, is that the techniques and the materials that we're still using haven't changed a whole lot from AD 100, AD 200. And just as some of these ancient structures endured the test of time, we're still using techniques that were used in Roman times to build. You know, on the right there on the top, that's a section of the wall from the Pantheon, and it's a multi-wide brick wall. Mind you, we don't get into too much core-filled masonry, but we still do build with exterior brick and brick cladded over masonry type structures. And on the bottom right corner is an example of a piece of travertine that was restored in the Colosseum. And the Colosseum is completely made of travertine, almost exclusively travertine. And they used bronze bars and anchors back then when they were setting those huge blocks. And we are still using steel in combination with stone today in order to restore structures. So my point is that over the ages, the techniques and the materials have not really changed a whole lot. My wife works in the dental industry, and we often laugh to each other of how similar the two are with each other. And that when I'm talking about cements and bonding and helical ties and restoring, she runs into the same topics with the dental industry. And I always say when I get questions about whether or not we can restore a structure is, what is your backup like? Is it solid? And it all really starts with testing on, how strong your backup is. And so, one of the key things with doing restoration work in dental is you need to have a solid backup. So your bone mass in your jaw is really this foundation for that. Without that solid bone mass in the mouth structure, you can't do a whole lot in terms of restoring teeth or doing root canals and so forth. And so what we do in restoration is often test first before we come up with a design. And what's involved oftentimes is doing a pull test on the backup with some of the anchors and ties that we're using in restoration. And it's not a complex thing. It's mainly applying an actual load with a test device, which will give you a value in kilonewtons, so the unit of force, the metric unit of force. Those familiar with Newton's law, 1 Newton equivalent approximately to holding 1 apple a meter in the air. So oftentimes when we do these pull tests, we will be able to observe how many kilonewtons of strength the anchors will present on the site. And a lot of our standards will very well describe some of the ultimate strengths that we should be seeing in these backups. So why do we use restoration anchors in the first place? Why would we get into this type of construction? and choose a restoration anchor of any type. And the reason is we a lot of times we want to avoid rebuilding the entire wall assembly by reinforcing an existing condition. Now, sometimes it's too late. Okay, on the left is a church which unfortunately was built where there were no ties whatsoever in the building envelope, and unfortunately it came down on a quiet Sunday morning on top of some new AC units. So sometimes it's too late to use a restoration technique, and there is no choice with this situation in this particular location but to rebuild everything and then install ties. But on the other parts of the building where it hasn't collapsed yet, a helical tie is a very good candidate for restoration. That's a picture of the spiral lock tie on the right. They're one of the most cost-effective methods of facade stabilization used today. They are low-cost helical tie, and generally speaking, they're as easy to put into a wall as putting a tap con in to install a hanging garden hose on your outside of your house, if you've ever done that before. Essentially pre-drilling a hole and using a driver tool to dry punch that anchor into a backup. And it's also used in embedding in horizontal joints and mortar and repointing techniques to help mitigate step cracking when we're doing repointing. It introduces tensile strength in the mortar joint in the context of embedding in a mortar and grout. So we're able to realize a very easy to install low cost method of restoration with the helical tie. Now another product which we deal with a lot is a torque lock. So that's the brand name, but essentially the torque lock anchor is a expansion anchor made of stainless steel and brass. So I describe them as the gold standard for connectivity. They're not made of gold, but they are very, very, very robust. And it is very hard to improve upon the effectiveness of a good old expansion anchor when we're talking about restoring masonry structures. It is just the most robust form of connecting, in my opinion. It is just so solid and so strong. We'll often do pull tests on these anchors and achieve extremely high pull-out values because an expansion anchor is just a very effective way at connecting concrete and masonry structures to each other. So these are very strong, very robust. They will not corrode. They outlast the life of the building, and a very, very viable way of restoring a veneer wall assembly. It's kind of a close-up of an example of how this expansion anchor functions. This is a piece of granite, but essentially you're activating a cone with a tool. That drives the cone in to open that expansion knurled area up and provide a positive bite in that area of the veneer and the backup. So it, again, is a way of avoiding the rebuilding of an entire wall assembly, so we don't have to tear everything down and make new again. Then it's just kind of a shot on the right there of how that looks in an older building, from the backup into the brick on the top right corner of that. Once it's engaged, it's a very solid connection. A lot of times in restoration work, especially in New York City, I know for a fact that there are trades who are dedicated just to shelf angle replacement. That's a very, very important method of restoration. It's important because you are supporting the masonry structure with the shelf angle, a lot of weight bearing down. And the reality is that the standards have for the longest time mandated only a oxide primed steel for shelf angles. I actually think that I don't understand why we don't use galvanized or stainless steel in that area, because we're talking about the through wall area of the building envelope. That's an area where the drainage plane changes and where water is supposed to find its way out. So oftentimes when restoring, we will come across corroded shelf angles that are needing work and replacement. Excuse me, just try, there we go. So when we do shelf angle replacement, in some situations, we may have the opportunity to be able to increase the quality of those materials from primed metal to galvanized or stainless steel. And if it permits, we may also have an opportunity, in not all cases, but be able to offset the shelf angle to allow for a continuous insulation to pass behind that air vapor barrier. So with our TBS system, we're able to, this is one of our feature products that we use. What it does is it brings that shelf angle outwards and reduces the contact of the shelf angle to the backup. So we're only connecting to key certain small points on the backup of the wall with the TBS system. I've got a couple of slides left to go here. We're about 55 minutes after the hour, so about perfect timing. And we're going to close out with two more methods of restoration, which I think are important to talk about because they do come up from time to time in my work. And people like clean buildings and they get dirty over time. But cleaning is really much a form of restoration work that's very important. It's super important to pay attention to the chemicals if we use chemicals in the cleaning of our buildings to make sure we're achieving desirable results. And one of our product arms, Diedrich Technologies, does deal with cleaning solutions. And the take-home message for today is that cleaning should be observed as something that we're dealing, if we're in the context of using cleaners and chemicals, chemistry really is something that is there to improve, again, productivity. Sometimes the use of cleaners discourages people because of, the description of the cleaner, their acids and so forth, which is true. But the reality is a lot of the cleaners we use in restoration cleaning are strong acids that are also have certain foaming agents to show that the work is happening, and they're diluted a lot of the time with a lot of water. So they're strong acids with water solvent carriers. Water is the universal solvent, and they're meant to increase productivity. And the acids can also be neutralized with bases to create a neutral solution. So what I'm trying to say is that we can safely and productively achieve cleaning results in restoration if we're cautious. And I always recommend before starting any cleaning project, because a lot of times there's a lot of unknowns with how things are going to react with the method of soiling and the backup and the chemistry of the actual material, is to always do a mock-up as you would do a mock-up on a job site of your detailing and your window projection. So always try a mock-up on an area of the building. Don't be afraid to get the owners and the stakeholders involved to make sure they are happy with that result. Maybe come back once or twice during the cleaning process just to make sure everybody's on the same page and they're enjoying and agreeing with the results that are occurring. So this is my last slide, and I like to kind of bring this up because it's part of a former life I had. I actually still work a lot with a colleague of mine from Spec. And if you ever go down to the World of Concrete or have heard of it and heard of the Bricklayer 500, he looks after that up here in Ontario. It's a bricklaying competition with big prizing. The World of Mortar is also, it's an entity all on its own, but it's also really pre-mixed masonry, mortars and grouts, something I have some experience with. Very, very important aspect of restoration work. And it's really what it is all about, is keeping that masonry joint intact and solid and free of cracks and filled solid, because that is our, one of our primary lines of defense. And in the fight against Mother Nature is the water membrane. Shedding water, brick does an incredible job of shedding water. And in order to keep it doing that, is we have to keep a close eye on the integrity of those mortar joints. And without integral mortar joints, a lot of those restoration anchors cannot perform. They rely on solid structures, solid mortar, solid brick in order to connect to. So they all are involved and connected closely with each other. So keeping an eye and somewhat knowledgeable of your mortar and grout standards, that's also kind of important too in the whole big scheme of things. So keep in mind, keep an eye on those mortar joints on your restoration projects, because the cracks are telling something needs to be done. Okay, so that's the conclusion of my presentation. I think we've got a few Q&A questions.
We do, yeah. And it looks like we are just at time. So if you want to hang on for 5 more minutes, we can run through a few of these if that sounds good. Any folks who want to stay can stay to hear 1 or 2. And then if your question doesn't get answered, we will have a record of it. So the Homan and Bernard or Blok-Lok team can follow up after the event. Cool.
Do you want me to read those?
Sure, yeah. If you want to pick 1 or 2 that seem interesting, we can get to those. Yes, it looks like some folks have stuck around. So,
okay. So I think first dibs is Andrew Pettit from, we use giant brick manufactured in Canada as the exterior as well as the interior finish claimed to be energy efficient. That I don't know about giant brick. I do not answer live. Should I hit answer live on this? Is that how I should do it?
Yeah.
You would like to answer this question live. Done. I didn't really answer it. I'm just kind of hit the answer. I guess my question to that is, that sounds to me like a brick that may have insulation built into it. And I have seen that with the block plant up here. Day and Campbell does that technique. And they do have R values associated with them. And I hope that answers that question. It really is almost the exact opposite of an insulated concrete form. Whereas with an ICF wall, you have insulation on the outside and your interior cell is concrete, whereas the insulated brick and the block is the reverse. So yes, you would have energy efficiency involved with that type of construction. Mohammed Umuru, how easy is it to fix the clips and brackets onto base wall? In event of a mistake in the point where clipper bracket is fixed, can it be unpinned and shifted to another point? Yeah, you could, because basically what you're doing is you're shifting that bracket over. If I can make it relatable, if you ever missed a spot on a wall, or if you're putting a Tapcon into a brick in the mortar joint and maybe that mortar wasn't so great, or you overturned the bolt and it isn't holding, it's just spinning, you have to go into another location. Usually within an inch is your limit, but if your drill hole is like right next to the other one, you're not going to be able to refasten in that area. Mind you, if you really had to, you could repoint that hole that you made somehow, maybe with some mortar, or use an expansion anchor in that place. But most of the time, the rain screen system is so adjustable that repositioning the clip, that's taken up in the actual rail and the girt assembly versus having to replace where your clip is located. And if it's really a huge problem, I would just install another clip and abandon that location altogether. That's a bit of a convoluted answer to that, but there's definitely options for clip and bracket systems on the base wall. Is that a structural ladder? I'm not sure what slide that is. Can't think of which slide that might have applied to. So I'm not sure. If you want to, maybe you could type another question if you're still on, maybe to specify where that meant. Anonymous attendee. Okay, Jorg, how do you diagnose that a masonry wall is strong enough to hold another veneer wall? Okay, the answer to that is, I'll use our Canadian standard as an example. The minimum strength of a masonry connector in Canada can't be any less than 1,000 newtons overall strength. And most of the time, the designer of a restoration project will specify what loads they're going to want to see based on a safety factor of that number. And oftentimes, that safety factor can be double the minimum. So oftentimes, 1,000 newtons, I will see bumped up to 2 kilonewtons. So 2,000 newtons or 2.2. That's what they want to see. The reality is you are going to get a pull test at what the wall gives you. The wall is going to give you a number. You are not going to be able to dictate what that number is. So I can tell you what I see in the field with Spec is we will see values of pull-out strength anywhere from 1 kilonewton up to as high as 3. So a lot of times the Spec will fall into that range. If you upgrade to a torque lock expansion anchor, you're going to see those values triple up to 6 to 9 kilonewtons. And the double-edged sword with that is that the cost also triples or even quintuples with the use of an expansion anchor. So it is definitely a factor, but the pull-out test values, they're really dictated by some of the minimums and the standards with regards to determining how strong the wall is. So that pull-out test device, that's a Hydrojaws unit from the United Kingdom. That's a brand, and that will attach to a wide variety of masonry connectors and give you a value and spit it out. So hopefully that answers that. And Andrew White, if you want to maybe specify what slide I was talking about while I'm answering these questions about the lateral, I can answer that.
It was a joke.
Was it a joke?
It was the New Orleans photo that had a ladder.
Oh, okay. Oh man, everyone's gonna think I'm super lame here. Emily Flournoy, you mentioned brick walls are great for directly anchoring for attaching new cladding, but what specific processes, products, or specs would you recommend to do this? Understandably, the structural engineer and cladding makers don't want liability, which can lead. That's a really good question. Specifically, with regards to a new cladding system, I get asked a lot of times. So for example, our easy bracket in our slide that I showed you, in a very basic description, they're essentially an L bracket fastened to a wall with 2 fasteners. And if your brick walls are in great shape, like they were on my university project, and you're using a legitimate tested fastener, and I'm talking about from a company like Hilti that has, R&D and technical data and testing like no other company does. If you're pairing a bracket like our Easy Clip system with a legitimate manufacturer of fasteners, you can even test those fasteners and test these brackets, and you're using a sound backup, you're going to achieve a very strong attachment to that backup without any doubt. And testing is definitely an important component of this, and that can be done in different ways. But I run into this quite a lot of times, with our 407 anchor. That's a masonry anchor we make for brick veneer, and it is really not that much different than the green screen bracket. It's an L bracket. It's attached to the backup. We have test data on that bracket. It can be stainless steel. And if you pick one of those things up in your hand, they are very, very robust. They're very strong, and they are tested according to the standards. So if you're doing all those things, then you're on the right path to ensuring your cladding is well attached. Okay, anonymous attendee. For retrofitting a single family house that has brick in the front and siding in the sides, what's your strategy for improving the insulation? I assume you would replace the siding, adding a layer of rigid. What would you do with the brick front? Would you insulate from the interior? Thank you. Great question. I see this in Toronto a lot because we have a lot of old 1930s, 1940s homes that are brick, and a lot of people do spray foam from the inside. That's an option. They will have to strip down the interior finish though. That's the downfall of that. If we're talking about siding, it wasn't that many years ago that our energy codes started driving the addition of rigid insulation on the outside of wood stud cavity walls. So that has happened already. And so that is a technique of adding insulation when you have siding. So a lot of times it doesn't make sense to add insulation to, well, another method again with the brick house is also to add EIFS. That's also another option too, I should mention, much like the apartments that I showed. So you have options to add insulation. I will caution this is that there are certain building conditions that exist, and Sarah Gray from RDH Building Science is an absolute expert on this topic. They have a study and a calculation and a formula, and they're pros on this. There are some buildings where if you do get into adding insulation, that you can create problems in the building cavity, which is, it's super important you avoid that. So when you're doing retrofitting and adding insulation, always talk to the experts on that, because there are people who know a lot more about it than I do, and Sarah is one of those people. So that would be my answer to that question. It's not just a straight answer, 100. It's not black and white. Okay, Jacob, I came a little late this seminar, so please feel free to disregard if you have already covered this. What are options for removing paint from brick? That's a great question. I actually did it for an aunt of mine who had someone spray graffiti on her house in Toronto. It was really nasty. And it was the first time I used a paint stripper. I was a little scared of using it because paint stripper is kind of one of the more volatile compounds that we use, because it is a caustic. So it is basic. So those of you who know what lye is, it's a alkaline substance that is it can corrode things very quickly. So there are a lot of precautions with the paint stripper. But I was surprised at how easy it was to use. And if you wear your goggles and your safety gloves and a paintbrush, it really wasn't that hard to do. I used a 606 paint stripper on a brick wall, and it was a spray paint on the brick wall. And you literally paint the paint remover on, and you let it dwell for I would say an unspecified amount of time. You really just have to see how things unravel. So I left it for a couple of hours on the brick wall, and then you rinse it, and it really worked quite well. We got most of the spray paint off, and that's one option for removing paint from brick. But again, you want to do a test area. If you have a large area that's been graffitied up, so to speak, you want to try a 1 meter by 1 meter or a test area to make sure you get good results, and then proceed with the whole project. So paint strippers work really well, especially for those really nasty paint stains that can happen. Do you ever seal a facade for waterproofing? Well, actually, yes, we do. And by that, what I mean is sometimes in masonry, we will apply water repellents in areas that may see a lot of water and freeze thaw. And I'll give an example of my home. One of my areas of my house that's exposed to the elements will get freeze thaw melting in February when the sunlight gets more intense. And what happens is I'll get a buildup of icicles on this one brick wall. When I moved here, it had gone through those cycles for 20 years prior to me getting here, and the brick was completely deteriorated. So what I did when I rebuilt the wall, which was a huge job, I put a water repellent on, which improved, it kept all of that water from soaking into the brick in these extreme freeze thaw cycles. It would bead off. And what's important about that is the siloxane compound in that, that will not block vapor trying to get out of the brick when it's dry. If it's trying to dry, it will shed the water. So try and think of it like shingles. Shingles on a home roof aren't meant to be waterproof. They're not going to be waterproof underwater, but they will improve the shedding. So our water repellent Omega Seal is an example of sealing brick. It's not a full waterproof, but it improves the water shedding of the brick. Okay, a lot of good masonry questions here. So a lot of people interested in brick. Last question I got from Anonymous is, for an existing masonry infill with great deterioration and many years exposed to the elements. This does not sound good already. Where do you draw the line when deciding facade replacement versus repair versus installing a new facade over the top? If the structure is 14-story concrete building with infill masonry on concrete block, lots of facade. The line is it's many things, and if you're not getting, if you don't have a solid backup and you are not achieving good strength, if you're installing restoration anchors into a backup that are not producing good pullout results, that are not compliant to the standards, and you don't have an option for solid connections, and you're really not going down the right path in order to, repair. New facades, rebuilding, you're going to know when repairing is the option and installing a new facade isn't. You really, again, have to have a solid backup. And if you're trying to install helical ties and expansion anchors, and the existing facade has more deteriorated and crumbly bricks than not so many, and then a rebuild is completely an option. So you can tell, I really feel like it's a lot of common sense. If the facade is so far gone that you're removing bricks and they're crumbling in your hands and they're flaking, and that's the majority of the facade, then to me it's very clear that a rebuild is in order. If your brick is good and your backup is good, and a restoration anchor is a candidate, then yourself or even your building envelope consultant will have a good plan in mind in order to achieve something that's a rebuild versus a restoration. So a lot of the times, again, if you're not comfortable, there is no harm in engaging with a building envelope consultant to further investigate that topic, because again, we're really good experts at providing these solutions and materials. That's the realm I live in. But there are people, like I mentioned, with RDH and Superstructures is another firm. These are the pros. And when you're dealing with expensive things like buildings, don't always invest in the professionals and the experts to also help. So that would be, I think that's the last question.
Yep, I think that's it. And yeah, just want to thank everyone who stayed on for a little extra time to listen to those responses. And thank you everyone for asking such wonderful questions. Thank you, Mark, for also taking a little bit of extra time to get to all the audience questions. Really appreciate it. And that was a wonderful presentation. So I hope everyone has a great rest of the day.
Thanks. Goodbye from Canada, and thanks for attending.
Right. Goodbye. Talk to you soon.